All right, at the end of the last problem, we saw that we were going to have model breakdown. Because the graph hit 0 at 30, around 30, let me zip back up here so you can see the graph. The graph hits here around 29 and a half. Everything after that point is model breakdown. It doesn't really exist. One could also argue there's probably model breakdown happening over here somewhere because, come on, 40% of 12th graders starting having tried smokeless tobacco is a little bit unrealistic. But we know that model breakdown for sure happens after 2020 because that would give you negative percentages, which is impossible. Which leads us to both the power and the pain of models. So modeling is when you take, we said it back here, oops, definition, several pages ago, but I'll say it again. Modeling is when you take a real life situation and you create a mathematical description, an algebraic equation, if you will, that models, quote unquote, that situation for you. It's a mathematical description of the situation. And usually at this point, we're going to have lines that do it. And then that means linear equations. So you have the line drawn, that's the model. And then you found its equation, which is also the model. That's the algebraic model, that's the graphical model. They're one and the same. When you do that, you have created something that's extremely powerful. And it allows you to make all sorts of predictions. You can predict what's going to happen in the future. You can predict what happened in the past, which isn't really prediction, I suppose, but estimate what happened in the past. You can go in the middle of the data that you actually have, which is right here. That's called interpolation. So if you see, there are the dots. Those are the same dots that are from our scatter plot. Right? This is still the smokeless tobacco stuff. That region right in there that's in the dots that we already had, that's called interpolation. If you make an estimate for a year that's in there, if I say to you, hey, what's happening at year 10? That's in the middle of these dots, so that would be interpolation. You're using the model to make decisions about stuff in the same time frame of what you actually have data for. Now, if I ask you to go in the past before what you actually knew happened, so if I say, hey, go back before 1992, because our first year was 1992. If you do that, then that's called extrapolation. You're extrapolating on the data from the data you have to some other area of the graph that you don't know. Extrapolation. Okay. Now you can go back in the past. So here's 1992, that big black dot, that's 1992. Before that, we don't have any data. So that would be extrapolation. We'd be extrapolating from our data saying, hey, if this trend continues, it should have been like this going down here, and it should be like, the other thing going up there, right? So you have two areas of extrapolation. You have the low area of it and then the high area of it. Okay. So you can extrapolate in the past, going before you had data. You can extrapolate in the future, after you have data, right? So you have two types of extrapolation. And then interpolation is in between, in between. Okay? And then you have model breakdown. That's what's happening on down here. That's what we just said at the end of that last question. We said, hey, this isn't making any sense. You can't have negative amounts of people, right, smoking tobacco, or what is it, using smokeless tobacco. That's what it was, chewing tobacco. You can't have that. So that would be model breakdown. It's not working, right? Cool. All right, so interpolation, extrapolation. So what am I getting at? Well, extrapolation's nice. I mean, it's upon this most of our society is built. You take data and then you extrapolate from there about what it's going to be like. So for example, you know that the oven is hot from past experience. That's your data. And then you extrapolate from there that when it's on, it's going to be hot, right? So I don't know, a stock is going down. So here's time, here's the stock's price. It's going down. So you extrapolate that it's going to continue to go down. Now, are there dangers to doing this? Yes, right? You can come up with data points that make no sense, or they won't work, or whatever. That's model breakdown. Or you can just come out with data points that aren't right. Maybe it starts going back up. Who knows, right? And we can't tell that from our data. So extrapolation is a very powerful tool. It's what allows us to, navigate the world around us. Is we take our past experience and we figure out that from judging from that past experience, this is how it should work in the future. But that doesn't mean that we're always right. And we can also get to the point where our model makes no sense whatsoever, which is model breakdown. All right, with that little tidbit out of the way, let's do another problem. Now this looks at first glance a little bit more like a traditional story problem. So if you're thinking, hey, where are the real story problems, Alana? Well, I'm about to give them to you. But it's even here, it's still going to have a little bit of a twist. So we have faculty regalia sell 16 graduation sets, cap, gown, and tassel for $31 per set, and sell 75 sets for $24. The number of graduation sets and the price per set in dollars are approximately linearly related. Find an equation of a model to describe the data. All right, now, the first thing you want to do when you set up a problem like this is you want to know your variables. Okay, your variables are X and Y, T and P, whatever you want to call them. I'm going to do X and Y because usually students are happier with those. Now, what is X for us? What's our independent variable? When you go into the faculty regalia store, do you say, hey, I want to buy a graduation cap, or do I want to say, hey, I've got 20 bucks, what can I get? Think about it. For buying graduation sets, it's going to be, I'm going to buy my number of sets. And then the money, the cost, is going to depend on that, right? I mean, if you want to walk out of there with, a certain number of sets, the cost that they're going to charge you per set depends on how many you're going to order, right? Now notice they're giving kind of a bulk discount here. So if you do 16 sets, if you just order 16 sets, they're going to charge you 31 bucks, right? And I guess I should say this is in dollars. Cost in dollars. Always good to have units, right? If they give you a unit somewhere like degrees Fahrenheit or meters or, $1 billion, 1,000 meters, stuff like that, you should be writing it. So this is cost in dollars. 16 sets goes for 31, and let's see, 75 sets goes for 24. Notice that the more sets you buy, the lower they're charging you per set. It's like going to a warehouse, right? The more you get, the lower, hypothetically speaking, the price is going to be per each item. But then you're stuck with 75 graduation sets, right? All right, now we're supposed to find an equation of a linear model to describe this data. Okay, so we're going to need this. Y equals mx plus b. It's a linear model, so I know it's got to be of that type. Now, I've got to find m. M is y2 minus y1 over x2, I messed up there, x2 minus x1. Okay, now what's y2? 24 take away 31 over 75 take away 16. Remember, it doesn't matter which one you put in as long as you're consistent. So if you're going to put the 24 here, the 75 has to go with it. If you're going to put the 31 up front, you could have done that, but then the 16 would have to go up front to go with it. They got to line up. All right, so what is that? That is 7 over, actually negative 7, right? Over 75 take away 16. So 60. No, I'm losing my mind. That's not 61. That's 59. Oh. Tired. Okay, so, and let's put in a decimal for that, because decimal will be more useful here. Let me grab a calculator. Let's see here. Negative 7 divided by 59. Enter. So 0.1186. So let's do negative 0.119. Cool. All right, so now I've got my slope. That's great. But that's not my equation. So I need to find the equation. So I'm going to have to say, okay, y equals negative 0.119x plus b. It's not really equals anymore because I used the approximation. So it's really technically approximate this, but whatever. All right, then I just need one of the points. So I could put in 16 and 31 if I like. 31 is equal to negative 0.119x plus, oh, not x, sorry, 31 went with 16 plus b. So I need to find out what this number is. So I'm going to use my calculator. And actually, if I'm crafty about this, I can just take my last answer and multiply it by 16. That'll even keep more decimal places. Okay, so 31 equals negative 1.898. 31 equals negative 1.898 plus b. Oops, plus b. And then I'm going to add, add 1.898 to both sides. Which means that b is equal to 32.898. Right? Now, if you use the other one, the other point, you should be very similar. Oops, I didn't finish writing it out. I better write it. It should be very similar, but it might not be exactly the same thing because we rounded. Or actually, we didn't round. And if you round a little bit, you're going to lose a little bit of accuracy. That's okay. It's not the end of the world. As long as you show your work, that's one of the reasons that I have you show your work. As long as you show your work, you should be around those values. So 0.119 and 32.898. Something like that. Might be 32.9, something around those lines. All right. Now I know you might have thought, oh, this step up here is kind of silly. Please, for the love of goodness, write that step out for yourself. Figure out what your points are from this little paragraph here and make notes about how your points are going to work. What's your x? What's your y? What are their units? Because you can use those to help interpret things later on. The last question is kind of a recap of stuff we've already learned. So let me add in here another column because we need to know the t values. Remember, year is almost never used by us. We don't really care about year very often. What we care about is time. And see, it says since 2000. You want to search for those everywhere. Look for your starter years. So your starter year is 2000, which is a nice easy starter year, which means this is 2, this is 3, this is 4, 5, 6, 7. We're supposed to find a linear model and verify that it works. Okay, we can do that. So we're going to go to our calculator, stat, edit, go up, clear, enter, clear, enter. So I go up, I'll show you again, up, so it's L1 is dark, press clear, enter, and it clears out the old columns. And then I'm going to type 2, 3, 4, 5, 6, 7. Then I'm going to go over here to the right, and I don't need year, I need 7.5, 8.8, 8.9, 9.0, 10.0, 11.2. Okay? So you type in all your numbers, right? Stat, edit, type your numbers in. Don't forget to use T. T is your L1. Better label that for yourself. T is L1. Skip over the year thing, and L2 is equal to the number of passengers that have been bumped. This is bumping means that you bought a ticket, but they knock you off of the flight and put you on a different flight because they oversold it. Okay, so then you want to find the equation, so you go to stat, calculate, number 4, press enter, and there it is. And again, if you got the news thing, you just have L1 as your X list, L2 as your Y list. If you want to store the equation, you don't have to. But if you want to, you just have to tell it under store equation, or if you're on this system, press variables, move to the right to Y variables, number 1, press enter. And again, the newer system, it's under store equation. That's where you put the Y1 in, under store equation. All right, so there's our equation. So let me type that up. Now be careful, you have to use the variables that you were given. So in this problem, you aren't given X and Y, you're given R and T. R right there, see it? R and T. So that's what you have to use. And then remember that this is always your independent, like your X over here with your L1, and then this is like your Y. They always do that in this book. Okay, so your X is your L1, your Y is your L2. Hold on one second. So there's your equation right there. Done. But you got to use the letters they give you. Then to verify, just go to your calculator, go to Y equals, it's plot on, zoom, 9. And there it is. And it lines up pretty well. Poof. And that's what I'll say over here. I drew a picture, and that's what you should do. Draw a quick sketch with the line on there to show that you did this, and then just say, yep, it does a good job of modeling those points, so it's a good model for the situation. Done.